These are the solutions to my one-page assessment, the higher version. There's also a foundation version. The idea behind this is you download this worksheet, complete it, send it to me, and I will mark it, grade it, and return it to you with videos on any topics you struggled with and further worksheets for all these topics. So it's quite a quick way of figuring out where you are in terms of the GCSE and getting instant feedback and further work. So this is available for £10 to get this service on my website, but I'm currently offering it for free. So when you're watching this video, maybe it isn't still free, but it was at the time I made this video. You can always check by clicking the link in the description or clicking the QR code above. Question 1, I'm just going to go through these questions, sort of explaining what you should do. If you do this assessment, I'll send back to you links to further, more detailed videos and further questions on each question. So if you struggle with linear sequences, you'll get a video through with how you do linear sequences and further questions on it. What I mean by linear sequence is it's going up by 4 each time. If it's going up by 4, it's like the 4 times table, which in maths we write as n. N being the term of the sequence. So for the 10th term of the 4 times table, you would do 4 times 10 because n would be 10. It would be the 10th term of the 4 times table. Now this sequence isn't quite the 4 times table because the 4 times table goes 4, 8, 12, 16, and this sequence is slightly different. So there's a couple of ways of figuring out how we adjust this. One is we figure out what the hidden number at the start would be. That's what goes here. It would be 3. So the sequence is 4n plus 3. So that means the 4 times table with 3 added on. Question 2, to find the volume of this cuboid. Quite simple once you know what to do. We literally just times the 3 sides together. So 4 times 7 times 3, which I think off the top of my head is 84 centimeters cubed. Yeah, that's correct. So important that you put the centimeters cubed because that's the unit that it's measured in. This volume is measured in centimeters cubed. Question 3, what is the interior angle of a regular hexagon? So this, in my experience of teaching people, this is something people struggle with. Now, one way of doing this is you carry on one of the sides and you create a straight line. And what we then have is we have an exterior angle, which I've marked there in that sort of orange, and an interior angle marked there in red. Now, because they're on a straight line, they add up to 180. And what that means, if you know one of them, you can figure out the other one. Now, the orange one, the exterior angle, is really easy to find. What you do is you always divide 360. That doesn't change. But what does change is you divide it by the number of sides. Well, this is a hexagon, so we're going to divide by 6. 360 divided by 6 is 60. So the exterior angle is 60. That means the interior angle is 120 because they add up to 180. So that is one way of finding the interior angle of a regular polygon. By regular, all the sides are the same length, all the angles are the same. The other way we could do this is we could know that all the angles in a hexagon add up to 720. There's various ways of knowing that or remembering that. And therefore, we would divide by 6 to find one of them. And we would also get 120. So the interior angle of a regular hexagon is 120. Question 4 is a reverse percentage. What we mean by that is we're not being told the original amount, we're being told the amount after it's changed. So if a TV is reduced by 20%, you're basically getting 20% off the price. So instead of paying for all of the TV, which would be 100% of the price, you're only paying for 80%. Because 100 take away 20, your 20% discount means you're paying for 80% of the original price. So this is key, the fact that 80% equals 480. This is the key place to start. What we now need to do, we're going to find 10% like we normally do, but instead of dividing by 10, we're actually going to divide by 8 because there are 8 tens in 80. And we have to do the same on the other side. So 480 divided by 8 is 60. the way we can do that is look at how many 8s are in 48. There are 6. So there are 60 in 480. And then hopefully we can spot from there times by 10 to get to 100%. 60 times 10 is 600. And generally in these questions, you get back to a nicer number. Like the TV started at £600. With a 20% discount, you get a kind of weirder number, the 480. So when you get back to the original price, it feels like a nicer price. What you can do to check from here is think, well, let's take 20% off. If you do, you get back to 480, so you know you have done it correctly. If you don't get 480 when you take off your 20%, you've done it wrong. Question 5. We have, and this is really important for the higher exam, a quadratic equation. By quadratic, it's got an x squared. Quadra means square. So that obviously quad means 4. I say obviously, hopefully we know that. But quadra means square. And the fact that there's an x squared in the equation means it's quadratic. Now, we need to solve it in the way you solve quadratic equations. We can't just make x the subject, which we would with a linear equation. What I mean by that is if we had an equation like this, we would say, okay, 4x, take off the 6 is 16, divide by 4 is 4. That's how you solve a linear equation. By that, it's x to the power of 1. The 1's not there. But because this is quadratic, it's got an x squared in it. We can't do that. We've got to do it a different way. And the main way you solve quadratics, and it's not always the case, but the main way, is by factorising, because it's just the quickest way. Now, it won't factorise if the answers are horrible decimals. We'll have to use a quadratic formula. But this one will factorise, and it factorises to x minus 9 times x plus 5. If you're not sure how to factorise, again, if you submit your question paper to me, and when I mark it and send it back, you will get a link to a video teaching you how to factorise and more questions on how to do this. So x must be 9 to make the bracket on the left 0, or x must be minus 5 to make the bracket on the right 0. Question 6, we're expanding 2 double brackets, and this involves surds. And before we get into expanding the brackets, hopefully you'd spot that the square root of 8 can be simplified. If you don't spot it, it doesn't matter, but it will help us here. Square root of 8 is the same as the square root of 4 times the square root of 2. You're allowed to break it up like that. And the reason you might do that is the square root of 4 is 2. So we can change it to 2 times root 2. So what I'm actually going to do is I'm going to put that in there. Just going to override that and put 2 root 2 there. So when I expand this, I'm going to use that rather than root 8. And to expand this, however you were taught to expand double brackets, I quite like using the grid for surds. That can help, but I'm just going to use FOIL for this. So first times first 12. You might not know what FOIL is. People get taught all manner of ways. 3 times root 2 gives us 3 root 2. And then we're going to times everything in the second bracket by 2 root 2. 2 root 2 times 4 is 8 root 2. I'm deliberately putting it there. And then last of all, we've got 2 root 2 times root 2. Well, root 2 times root 2 is the square root of 4, which is just 2. So if it's 2 root 2 times that, it's 2 times 2, which is 4. So we've expanded the brackets, we've done the 4 multiplications, and now we're just going to bring it all together. We're collecting up the like terms, so we can add together 12 and 4 to get 16, and we can add together the root 2's. We've got 3 root 2 plus 8 root 2, which is 11 root 2. Question 7, we've got to work out the area of a sector. Now, you should be getting the formula sheet for the next 2005, 2006, 2007 GCSEs. So if you're watching this video, you're probably going to get the formula sheet. I doubt this video will still be around when they take the formula sheet away. So you'll be told on the formula sheet this. The area of a circle is pi r squared. What that means is you would times pi, which is 3.14 roughly, by the radius, which has been times by itself. So for this question, pi times 6 squared, which is 36 pi. Now that's the area of the whole circle. We've got a sector, so we've got part of a circle, so we've got to figure out how much of the circle we've got. Well, we have got specifically 120 of the 360 degrees. Hopefully you'll spot that's a third. If you've got a calculator, you can just type this in the calculator and it'll do it for you. We've got a third of 36 pi, so we would do 1/3 times 36 pi, which is 12 pi. So that's us leaving it in terms of pi. And we have to be specific here and say 12 pi centimeters squared. If the unit's not written on your answer line, you have to make sure you put it, otherwise you'll lose a mark. If you're not confident with finding the area of a circle, start with that, practice that. There's some questions on my website. And then once you're confident with that, you can start looking at finding the area of a sector, which is like a fraction of the circle. Here we've got y is directly proportional to x. So what we can say is y equals k times x. So k is the constant we use for a proportion. And we're going to say we're told that when y is 12, x is 8. So we can put that in and figure out what k is. So k times 8 gives you 12. So k is whatever 12 divided by 8 is. And that's 1.5. So we now know we can rewrite this formula as y equals 1.5x, because we know what k is now. So when we're told find the value of y when x is 10, well, y equals 1.5 times 10, because x is 10. 1.5 times 10 is 15. Again, if you do this assessment and send it through to me, I will send you through my handwritten solutions to this paper, which are a bit more considered. I try and use colors in my solutions so that if you're looking at them without watching a video, you can maybe understand what I did. Here, I'm just quickly going through it with the colors that come to hand. Question 9, fairly easy, but often done wrong. 6 people take 12 hours to do a job. Now, the common mistake is that people think, well, 3 people, I'm dividing by 2, so it will take 6 hours. We'll divide that by 2. But actually, this is an inverse relationship. If you think about it, if there was half the amount of people to do the work, it would actually take twice the amount of time. So 3 people would take 24 hours to do the work. That's a really good example of what an inverse relationship is. As the number of people goes down, the time taken goes up. And if we increase the amount of people doing the job, the time taken to do it would go down. 10, we're on to proof. So if you're not sure about proof, definitely worth watching some videos on how to do it and having a go at some questions on this. You need to be confident on what consecutive integers are written out algebraically. So if we're going to use n, so n is for integers, it's a whole number. It can be any number, but the number after it would be one more. So n, and then n plus 1 is the next number. So we're going to use these in our proof. So the sum of the squares, so we're going to square these, so it's n squared, and the sum means to add them together. And we've also got a square n plus 1. Now, my experience is if people don't write this as double brackets, it goes wrong. So it's n plus 1 times n plus 1. Well, n squared is n squared, and if we expand the other brackets, we get this. If we add it all together, we get 2n squared plus 2n plus 1. And we're being asked to prove that it's odd. Well, the reason this is odd is 2n squared plus 2n is even, because you can take 2 out as a factor. So 2n squared plus 2n plus 1 must be odd, because we're adding 1 on to what is an even number. Question 11, we're doing completing the square. Depending on where you are with your course, if you're doing the higher GCSE, you might not have even been taught this yet. And some of these topics you might not understand because you've not been shown them. Completing the square is the idea that this won't factorise, but we're going to try and force it to factorise. So what we do is we always halve the coefficient of x there. We're going to halve the 8 and say x minus 4 squared. The reason we're going to do this is if we expand this, I'm going to write it as double brackets like I just said, we get x squared minus 8x plus 16. So we kind of recreated the first part. But instead of plus 21, we got plus 16. So it's not quite right. We've actually got to add on 5. So completing the square here is to say that it's equal to x minus 4 squared with 5 added on. That is the same as x squared minus 8x plus 21. And there's a few things we can do with that. We can do things like finding the turning point. We can even solve a quadratic using that method. But for now, if you're not sure on completing the square, it's a good thing just to practice doing those. It's quite easy to start with once you get the hang of it. And question 12, this is a combining ratios question. So what I find always really helps is to put A to B to C, and then we're just going to put in A to B is 8 to 7. So I'm going to put that there. And A to C is 10 to 7. So I'm going to put a 10 under A and a 7 here. And what we're going to do is combine them into one ratio. And to do that, we're going to come up with a number here that's a common multiple of 8 and 10. So you can always times two numbers together to get a common multiple. But rather than 80, if you spot that 40 is the lowest common multiple, it makes everything a bit easier. To make the 8 here 40, you times it by 5. So we would times that 7 by 5 to get 35. For the 10, we would times by 4 to get 40. So we're going to times this 7 by 4 to get 28. So that's the ratio combined. That's the ratio of A to B to C. And it wants the ratio of B to C, which is this bit here. So we've got 35 to 28. And it says give it in its simplest form. If it ever says that, it's a clue that it probably will simplify. Hopefully we'll spot that 7 goes into both. So the ratio of B to C in its simplest form is 5 to 4. Question 13 here, we've got some simultaneous equations. They're linear, they're not quadratic. And the method I tend to use for this is we're going to eliminate either the x's or the y's from the equations. Now, if we look, we haven't got the same amount of x's or the same amount of y's in either equation. So we need to change them so they've got the same number of x's in them or the same number of y's. Let's go with x. It's kind of a good idea. If in doubt, just go with x. So we need a common multiple of 3x and 4x. If we times 3 and 4 together, we get 12. That is the lowest common multiple. So what we're going to do is times the top equation by 4, all of it by 4. So we get 12x plus 8y equals 16. And then for the one underneath, to make that 12x, we're going to times by 3. I'm quickly going through this. I'm not really explaining too much detail. It's not really the time and place to teach this topic. If you've got no idea and you've never done it before, then this is something you need to be looking at, how you solve simultaneous equations. This is on the foundation paper as well. So it's definitely a skill you need if you're doing the higher paper. And what we're going to do now is, because they've got the same amount of x's, we've got 12x in both, we're going to subtract one equation from the other. I'm actually going to take the top one, the red one, away from the blue one, just so I don't end up with negatives. So 12x, take away the 12x above it is 0. That's the whole point of this. We can't solve an equation with two unknowns. 15y, take away 8y is 7y. And 51, take away 16 is 35. And I'm happy because I now know that 7 goes into 35. I've got a number 7 goes into. So y is 5. What we now need to do is figure out x. So we're going to substitute back in to the original equations. I'm going to pick the top one. And I can say, right, 3x plus 2y, so 3x plus 10 because we think y is 5, equals 4. And I can just solve this little linear equation here. Take 10 from both sides. I get 3x equals minus 6. So x equals minus 2. And I could check by substituting both of those into the second equation, see if I get 17. 4 times minus 2 is minus 8. Plus 5 times 5 plus 25 does equal 17. So at that point, I'd know I've done it right. Question 14 now, we're almost done. My experience of teaching this is if you know what you're meant to do here, you'll just go ahead and do it and get it right. And it's the people who are like, I just don't know what's meant to happen here that don't get these questions right. What we're going to do, and you might see by what I've already marked on here, is factorize the top expression and the bottom expression. And what we're expecting is to get a bracket on top that's the same on bottom. And what we can do then is just cross them out. So knowing that's what's going to happen, it's actually going to help us to factorize these. I would always factorize the top because it's got a coefficient of x squared of 1. We don't put the 1 there, but it is. It's going to be much easier to factorize than the bottom. And I spot that it's x plus 9 times x minus 2 that expands to give me that. Now, what I would do, having done lots of these, is straight away put the x minus 2 on the bottom, because I know I can times to make 6 from 2 and 3. I can't get to 6 from 9, so it's not going to be one of the answers. I know that to get 2x squared, one of these brackets has got to start with 2x. And I also know I've got to put a 3 in the other brackets. They multiply to make minus 6. And it would have to be a plus 3. So it's really helped me to factorize the one on the bottom. Obviously, check and expand, see if that is actually how you factorize it. And what we can do now is cross off the x minus 2 from top and bottom and say this simplifies to x plus 9 over 2x plus 3. So that's simplifying algebraic fractions. Once you do enough of them, you're really happy to see it appear on the exam. And then the final thing here, triple brackets. Again, if you practice these, it's really nice, easy marks. And the good thing about this as a topic is even if you get it wrong, you should get all the method marks. Maybe not the final mark for the answer, but if you know what you're doing, you should pick up lots of marks. So the way to do this is to pick 2 brackets to times together first. And you don't have to do it in the order it's given. I'm actually going to times these 2 together first, so that finally at the end I can times by x plus 5, because I've got to times 6 times at the end with that. That'll become clear when I do it. So multiplying these 2 together, I get x squared minus 5x plus 6. And I'm now going to times this by the remaining bracket, that x plus 5. And I've left this one till last because I've got to do 3 multiplications with it with x and 3 multiplications with it with 5. So I times everything by x. Timesing by x is quite nice here. Nothing's really changing. You're kind of just increasing it by a power of x. And then I'm going to times everything by 5. And again, not too bad. And we get minus 25x, and we get plus 30. Now I set this out deliberately like this so that we can add the like terms together. What I mean by that is I've left these there so they add together, these there so they add together. So just x cubed, there's no other x cubes. Minus 5x squared plus 5x squared, they cancel each other out. 6x take away 25x gives us minus 19x. And then we got that plus 30 on the end. So that's how you expand triple brackets. Really practicable. If you go away and sort of practice doing that, checking your answers as you go, you're going to be happy to see it on your exam. It's nice, easy marks. So those are the solutions to my 1-page assessment for the higher paper. If you've watched this, hopefully you've done the assessment, sent it to me, and I've sent it back to you. If you just wanted to watch, that's great. But it's what I send back to the students that send it to me that they find really useful. It's the solutions, it's the extra questions, it's the extra videos on these topics that really helps them. So please do download this worksheet, you will find the link in the description or the QR code and send it to me, and I'll happily mark it and send it back to you.